And also, a lot of these models are becoming open source less and less. So today I'm going to ask, what can we do about it, and what interesting questions can we still ask about it, and what innovations can we do to help actually make more models be able to be open sourced. So I've recently had my work featured by Mozilla and PyTorch as well last year. I do a lot of, I'm currently a PhD student at Cornell University working on this very question: how do we actually make open source models more accessible, more easily used, and why should we actually do that in the first place? So I've done work on this from a variety of perspectives, particularly looking at the data sets that go into these models, how we can improve them and how we can train them. Actually training some of these models. I've worked on several large open source LLMs, including DBRX, Bloom, and OpenGPT-2, as well as some genomics and diffusion models. We're going to be chatting a bit about one of the more recent diffusion models work, because I think it's actually a very prime example about how we can actually move forward in the space and do interesting research. A little bit on the law and policy side, because I find that actually this is one of the main barriers that is preventing a lot of these models from actually being open source more easily. And finally, just making training more efficient. Obviously, this helps at all scales, but particularly in resource-constrained communities like open source collectives doing research, or academics, or just people trying to actually have faster iteration cycles to do good science. It's often a really large bottleneck. And I've also worked on tooling on this, from Habitat Sim to PyTorch, and just various parts of Stack in general. So I'm going to split this into two main sections of my talk. First, I'm going to have general thoughts about the past, present, and future of open source models. And then I'm going to focus more specifically on CommonCanvas, which I think facilitates how we can actually move forward, and give a little preview about some of the work that we're currently doing to make this, extend this to other domains as well. So I also mentioned this, I'll also save 5 minutes at the end for a Q&A, but just rhetorically, what does openness in AI mean? So there's various different levels of openness. We can have open efficient training infra. We can have the actual source code for the models and how to train it. We can have the data sets used to train the models as well, or at least how to create data sets that are similar to those used to train the model. We can also just have the paper, open methodology. This is like GPT-3. We know roughly how GPT-3 is trained. We know as these papers get more and more recent, there tends to be less and less interesting information about the data. But at least there's some fun architecture and efficiency stuff in there usually. We can have the open weights. We can have the evaluations used to train the model. It's actually, ironically, one of the rarest things to actually get these days. Llama is a great example. Llama meets a lot of these criteria, but we actually don't know how they chose to collect, train data, and evaluate Llama. We know what benchmarks they published, but those may or may not be the benchmarks they actually cared about during training. And we also like the models to ideally be somewhat unrestricted, or at least have defined licensing terms, and not just be like, hey, we trained a bunch of stuff on the internet, we don't know where it's from or why, or what's in it, or what parts of the world it actually complies with standing law, et cetera. Because if you're actually trying to deploy a model, particularly a large company, this is going to be pretty difficult. And it didn't always used to be like this. If you just go back about 5 years ago to GPT-2, before then, people basically open sourced all their models. People released training code, data, the whole stack. And then OpenAI came along, and ironically decided not to release their model. There's supposed to be an image here, but it's not loading. But anyway, so circa 2019, I decided to actually go and recreate GPT-2, and we released the data set and the model. Honestly, the model people don't really use much anymore. The data set is still very actively downloaded, and it became OpenWebText. And it's now used as the benchmark for thousands of models, as well as dozens and hundreds of academic papers. So that's obviously one really good reason why we should have OpenAI. Actual OpenAI. I have to do Open Common AI now, because ironically, the name does not actually apply to the company. But the question is, where did it go after that and for other reasons? Well, there's several reasons why these models aren't as open as they used to be. Engineering costs exploded, and frankly, the training code is not as generic and might rely on a lot of special internal tooling. Compute costs have exploded. If I spent so much time training and money training the model, why should I just give it away for free? People think, and then the big reason though is people started to make money off these models, and then people start to care about the provenance and legality of these data sets. And people, if you're just doing work for the sake of research, people don't tend to actually care about how these models are trained. If they start actually selling it and making billions of dollars off of it, that equation changes very quickly. There's also, more recently, regulatory and disclosure requirements and lots of pending legislation to add more of those, which can make it difficult to open source models. A lot of the more recent open source models are not available in the EU for this reason. And because they're becoming the product, people don't want to give away the product, even if it's a worse product. And ironically, I think one example is that the really good models have gotten so good that people don't feel the need to open source the bad models, even though there's a lot of really useful information to be gleaned away from this. I also would like to add that we've, on the point of giving away the product for free or giving away the research for free, to hone in on this, attention is all you need, great paper, got a lot of citations and kind of drove the field forward. And that company that released it, Google didn't actually benefit from that immediately. It was other companies that went and actually productionized it. And we saw a similar kind of visceral reaction when the iPhone came out in 2008. Because actually, if you look at the research studies that were used to decide why we should prefer a touchscreen interface, why people actually would want this, ironically, it actually mostly comes from Microsoft for the past 10 years, but they just never were able to actually decide to put it into an actual device. And so that changed the research culture, and we're seeing a similar kind of change in the research culture now, where people don't actually want to open source the models or release the models much. And this creates a lot of these issues create chilling effects. People cannot talk about data sets even if they want to, because it makes you an easier target for litigation. And unfortunately in the US, where even if you have a really good defense for litigation, you still have to go actually spend time and money defending that in court, which is not ideal. Often, a lot of the important revelations in post-training actually are done by human annotators. And a lot of these companies, wary of AI replacing their jobs too, actually explicitly prevent in their contracts from companies releasing large portions of their data sets. Once again, what's the point of it not being, if it's not good as OpenAI and Llama, why should I care? And why should we give away our R&D once again if we're not going to productionize it properly? And then this way the question, why should we actually care about models being open source? Because people can and will improve on them. We've seen this a lot. A lot of the best innovations we've had in LLMs have been from academics and the open research community, from linear attention, Mamba, flash attention. Essentially, a lot of the stuff, minus some of the stuff that GNOME has done, and a lot of the great stuff that Eleuther academics and everyone else has done, has really helped actually move the field forward, publicly at least. And a really important thing is, as we're trying to regulate these models and regulate how they're used, it's important to understand how they work and why they work and what their failure modes are. If we don't have access to the model weights, if it's all hidden behind an API, and if you try to get around it, you're going to get banned as a researcher, that makes it very hard to do research on them. There's also a good bias here about what important questions about these models are companies not asking, either because they might not like the answer or because it's not viable for their bottom line. And I think also a really interesting point about this going forward, about whether it's going to actually be open source or not in the future, is Gen AI going to continue to be a product, or just going to become another piece of infrastructure? Historically, we've seen open source thrive in places where it's a piece of infrastructure. PyTorch is a great example. It's a tool that people use to build on top of, but it's not necessarily the end product in itself. Linux and other things where usually a place where a closed proprietary system does really well is something where it's mainly a UX tool, something like Photoshop, Photoshop versus GIMP, or Unreal Engine, or all these other things where you're actually interfacing a lot with people, and you actually need to spend time, money to design and keep it up to date. And finally, one important reason is just to shine a light on dark knowledge. And there's a ton of really important research being done here, and people aren't publishing it. It's important that at least other people try to publish it. Let research ask questions that people don't even think to ask. And I'll give you a really cool and really actual example. So shortly after OpenWebText came out, Google put out C4 dataset. It's one of the other really popular datasets to train large language models on. It was also very nice and clean. From a copyright perspective, it's just all filtered common crawl. They did very simple filtering because they just wanted to write a paper on it and get it out. And this has been used for a lot of actual production language models later on because it existed and it's there. And one interesting oversight in the original work was propagated to several actual deployed systems is that one thing they did to try to filter it and remove nudity and various other, lurid content for the dataset was like, oh, there's this nice filter list for images of bad words. Let me go and filter any document that has those bad words out. And then you actually look at those lists of bad words years later, and you find really, say, problematic words to filter out. Things like gay, homosexual, OMG, menstruation. And obviously, this is not great for marginalized communities, and this is not something that would be even known if these data sets weren't public to free researchers to go and ask these questions to begin with. And so I think one real important thing to actually do good science to make these models better is to actually have consistent data sets that we can actually share. And we're right now seeing that open AI is in crisis. You can also argue open AI is in crisis, but that's for a different talk. Open models are great, but they're also becoming a little bit more restrictive. Open weight models are starting to take over now, but they're not as transparent as a lot of open source models. And no one wants to talk about the data anymore. Because even if they're very confident in it, they're 99% sure about it, they don't want to give any ammunition for people to launch litigation against them. And working on data is high impact. Model architectures are more or less stabilized. If you read all the papers, Gemini, Llama, or at least anyone who's talking about their architecture, they tend to all more or less be very similar, if not the same. And really, a differentiator is the data. There is still room for architecture advancements, particularly if your data is not in the classic text domain. We have a really cool paper on this called Caduceus/Plant Caduceus, where we have an LLM that's specifically designed for DNA sequences, and it actually has very different assumptions than an LLM. And you actually need to be able to pre-train it. So actually knowing how to be able to pre-train these models is important in that context. Virtually all the gains we've gotten recently in LLMs, with maybe the exception of GPT-01, has been solely in the data. And now it's a growing discipline. There's more and more people doing the data work, but it's still less compared to the number of people actually training these models, it's actually less and less than it proportionally was before. And one really concerning thing is open data is becoming way more scarce. So a lot of these companies, nonprofits, and everything else training is just went and mined existing public domain, Creative Commons, et cetera, content for this data, including scrapes like Common Crawl. And suddenly, they started signing large licensing deals for some of this data, and companies want to maximize the revenue and not give away their data for free. This is a great graph from Sean, one of Shane Longpre's works on the Provenance Initiative, and basically it shows that as you look over time, people didn't really care about blocking robot.txt and Common Crawl on their website, and then suddenly after GPT-4 came out and ChatGPT, then people really started to suddenly block all content quite aggressively, and this made it harder for researchers to do their job. One really good example is the Reddit push-shift dataset. It used to be one of the standards for training LLMs. You can still access old copies of it, but it stopped being updated mainly because Reddit wanted to start selling data and going so far that they've even started to block Bing entirely from indexing their website because they don't want any of their data to go into Microsoft products because Microsoft has not agreed to pay for it yet. So it's got, so obviously, this is terrible for people who want to train their model from scratch and open researchers. And it's even worse considering that a lot of the companies have already downloaded all this data. They already have it. And really, all you're doing is making it harder for incumbents to get in the game. Even Common Crawl itself is not safe. They are in mired of lawsuits right now about removing past content they've already crawled from their site. As I said before, more sites are banning Common Crawl since it's used to train commercial AI models as well. And startups are not respecting term, source, or copyright rights text at all, burning free will and making it harder to access legitimate public data sets, public domain content, Creative Commons content. And even if none of those things are true, just if the only source of data is to go and download that data, and you're downloading, let's say, a petabyte, or that's maybe 100 terabytes of data per dataset download, that's fine if you're just a one-off. But now if I publish a dataset that's really popular, like say Lion or another linked dataset, that suddenly becomes a very high cost for the company to bear, and they will just block you because they don't want to pay the high AWS fees. And again, companies are archiving data, but they're not releasing it. How can we save this data? And the issue is you can save the data, but once again, because of the content data, it actually becomes very hard to redistribute and share with other folks or rehost because you have all this. It's basically a potential legal ticking time bomb. So the question is, this isn't just about LLMs. This is about all modalities, but particularly about things that we have monetized in the past, which is text, images, and especially audio, but that honestly warrants its own talk for a lot of really interesting policy and legal reasons. And we have an uncertain future about ASIP, whether scraping itself is going to be fair use, whether being able to go around, whether robots at TXT is going to have to be legally enforced in law and respected. We're not going to get legislation to solve this anytime soon, especially because it's an election year. As architecture converge, once again, training data, way more important. Training data may no longer be free and accessible. So what can we do about creating open source data sets that can actually be shared, that can be held to a higher standard, and that we can actually come up with practices that may be used in real LLMs to avoid issues like that bad words text case we mentioned earlier. And as people who aren't actually developing the product, that's really the only people who can actually go and look at this with scrutiny and decide what we can actually do about it. So what can we, and I'm going to do a quick aside here, what we can do aside from just collecting these data sets and training these models that you can do for openness, and one is just advocacy. So there's really 3 prongs of training these big models: data, efficiency, and evals. And these are all things that you can actually work on at small scale. And one other really big friction right now for the open source models, as I mentioned before, is AI regulation and policy. I advise 2 policy nonprofits right now that are trying to shape AI regulation. And one important thing is when people discuss these, often they don't actually have any specific carve-outs, exceptions, or thoughts even about what open source models are and how they fit into this. And often it's like, oh, you should go and pay for an audit of your model every year, which is an actual provision in the proposed California Senate bill. And obviously that's one thing if you're OpenAI and you thought you're making money off your model, but if I just want to release my model as a one-off because it's related to a research paper, or if I'm a nonprofit, this is obviously non-tenable. And it's just a very small case, and there are so many other cases where this actually becomes way more problematic. So advocate, tell your lawmakers, and say that you support open source and why it's actually important to you. But yeah, and okay, so now for the running short on time, so I'm going to focus on the main presentation, which is CommonCanvas and Common Catalog. So we mentioned this question about data. So what can we do? We can try to archive and save the data, but the question is then how do we redistribute it? And we run into a lot of these problems anyway, where a large company might train a model on the data, and then they can't release that model because they're uncertain about the origin, provenance, and quality of data. And a lot of this comes down to copyright, and I could go into a whole separate talk about this and about the open questions about whether or not this is actually a problem in the first place. But at the very least, it's a source of uncertainty. And the issue we mentioned before, linked data sets, is you cannot redistribute the images easily. because that's probably, even under the more generous interpretations of the current law, that's probably not the best thing to do. Your data can be poisoned, and this has actually happened in the wild with Lion data. Some of the original Lion data has been data poisoned by people. It's also just a big pain to download, and websites might block you because they don't want to pay for the bandwidth cost of downloading their own data for using these data sets. And link rot ensures that no two downloaders, given enough time between the downloads, will ever get the same data twice. And that's entirely separate the fact about whether the download succeeded or not. This hurts reproducibility. Data is not hosted anywhere. There's also a whole fun thing here about people not wanting to use diffusion image generation models because it's trained on their data, and people don't like. So can we actually train on an AI model, image model on a subset data, which is more principally licensed and that doesn't have these concerns? So yeah, how can we make like stable diffusion reproducible, open, and accessible? How can we make it cheaper to train? There's a lot of things you can do here. Surprisingly, the original paper didn't have flash extension. You can use torch compile. You can use fully sharded data parallelism. You can pre-compute the latents, use low precision layer norm. And these are all things that are common, but they're not actually available in an easy way. You use framework in a lot of open source code, especially when this was written, so people didn't know about it. And therefore, if you weren't at a PyTorch System conference, you might not even know about all these features you can turn on to make it more efficient. Yeah, do we have enough images to train a diffusion model? Can we do it without copyright data? How can we get the captions, and can we train good results? And what differences do we occur between the data, this data, and the greater superset of data? And so let's look at Creative Commons images and where to find them. And there's a lot of fun technical challenges here about getting rate limited, about getting IP banned, about actually downloading and storing petabytes of data and getting them either from the website itself or the Internet Archive. And finally, the funnest one, convincing lawyers to let you release as much data and finding a place to host it. So the first question, okay, we found this data set, 100 million images. It's less than 10% of what was used to train Stable Diffusion. Can we do it? And so we actually just kept the iterations fixed, trained the same data for longer, and surprisingly, we found essentially no difference here between the different splits of data. We don't have captions for that data, though. So how do we actually train on it? Well, the captioning models are really good. When this paper came out, this was a novel result at the time. Now we know that this actually works so well that everyone's doing it. DALL-E 3 and virtually every other image generation model since then uses synthetic captions because they're now better than human-generated captions. But we did that, and we didn't do any filtering. We just took the first caption out of it, see like what the baseline is, what's the worst result you can get, and it's actually still pretty good. So we trained a model, some results here on the right. These are all on Creative Commons images, and more or less you get data that looks really nice, and the images are pretty and usable. You can use it. You can go look on Hugging Face and actually play with the model. And we go evaluate how well it works. Turns out it works pretty close to the original model, except for a small number of categories like faces and individual people, which is actually a potential benefit depending on how you look at it. Synthetic captions are actually really bad quality. And so you don't actually have to make captions that are that good to begin with. So here's like a real example we have of a caption from the image dataset. And obviously something that sounds like an ad's view of latest IP1PC transparent gradient color voila curtain is obviously much worse for training a model than a living room with a white couch and curtains. So we go and we actually compare in a user study how well this does to Stable Diffusion. And it turns out to actually a little bit worse if you keep the parameter count the same. But if you make the model bigger and make it SDXL size, it actually does about the same, which is really cool because, once again, all the training data is Creative Commons, and therefore, even under the strictest interpretation of copyright law and fair use, is fair game to use and significantly easier to collect, train on, and most importantly, redistribute. So a whole data set is available on Hugging Face. You can download it. It's hundreds. It is one of the largest data sets currently hosted on Hugging Face. But you can go access it and download it and see exactly the model it's trained on and do a lot of really interesting research there. And there's actually some really positive effects here of using synthetic data. One thing here is that you have all these various loaded prompts, like an image of Elsa from Frozen. That could be any person named Elsa, but if you do Stable Diffusion 2, you always get the Disney character. Or my favorite one, the Lion King, could be any lion who happens to be a king. But if you use Stable Diffusion, you always get the 1995 Disney movie and not a lion sitting on a throne with a crone. And then you have some other fun loaded concepts here, like Ice Princess. You will take it out with Elsa, Snoopy, or one of my favorite is an adventurous archaeologist with a whip and fedora. Could be any archaeologist with a whip and fedora. Could be any gender, but no. If you do Stable Diffusion, you always get Harrison Ford as Indiana Jones, always. Or a teenage wizard with round glasses. Could be any teenage wizard with round glasses, but you'll always get Harry Potter. So these are like some fun ways in which you get a model that's actually more creative and less constrained by popular culture and media. And finally, it's actually because you're using a captioning model, it doesn't know individuals as well, and you kind of smooth out the edges of the distribution, which means that it's actually hard to generate celebrities and create problematic deepfake content stuff with just a text caption. So once again, yeah, you can train a really good model on not copyright data. It's all open, public, and available on Hugging Face. Encourage you to check it out. We can do really well with less high-quality data, and we can actually redistribute the data. And we didn't need to do any caption filtering or upsampling, and it still worked well. Obviously, we really should in the future. Currently working on a V2 where we actually clean data a little bit more, provide more data, and have it work better. And one ongoing research project we have right now is, can we use this for LLMs as well? We're currently collecting a large data set as a V2 of the pile called CommonPile, along with a bunch of other collaborators, and we're going to try training an LLM on it and seeing how well that does on these various LLM tasks, despite not having any of this other potential content in it, like, say, Books 3 or various other problematic legal sources, and use that to actually train a good model. And to acknowledge people who have been stock, like Databricks providing compute for CommonCanvas, my research advisor, teammates on the Databricks Vision team, and helping actually set up the info for this, Hugging Face for hosting a really large data set, and AWS for helping me host the next and larger version of this data set, and also I need to really go move this data set over to AWS after this. But yeah, you can go check it out online. It's all available on Hugging Face. And yeah, I can open the floor to questions. So yeah. Or I guess there's a mic set up over there. So. Okay, yeah, okay, so yeah, I didn't go too much into the efficiency. So the question is, like, what does it take to actually train this model from scratch? And I didn't go too much into the efficiency stuff because there's a ton of talks doing that at this conference. So the question is you can train a low-resolution version of this model for 2 weeks on a single A100 node, or 1 week on an H100 node in theory. For that 2 week 626 resolution, obviously you need higher resolution, you can do better, but these are diffusion models, they aren't resolution sensitive, so you can get really quick iteration time with small models and scale up as needed. Yeah. Okay. Any other questions or? Sorry. Sorry. So you said synthetic data from large language models? Yeah, I definitely do think the question is, does synthetic data generation going to lead to algorithmic improvement in training these models? I definitely think it's the case. One point of this work is to help make this a little bit legally less murky, so people can actually open source the models and get it past their legal teams and lawyers. That's a little bit more challenging in that context for a whole bunch of reasons, including if the model's behind an API, what the terms of service allow for the model, are those terms of service are enforceable? These are a lot of interesting questions that have not actually been resolved yet. It's obviously very possible if your model is actually open source, like some of the Mistral models, where it's just actually an open source license. But it's a complicated thing, and like we know for a fact now that synthetic data helps the LLMs. It's pretty clear that GPT-01 used a lot of synthetic data to help fine-tune or guide it. And as these models get better, it makes sense that it's going to be more and more synthetic data. And if you can create if you have a bad, like, not quite as good language model, but one that is permissively licensed and use that to generate synthetic data and improve that model iteratively, that is a really cool and fascinating avenue of research. Or if you can use a proprietary model to guide this generation or selection to make it even better. Those are all ways that you can actually have an open source model, an openly licensed model that matches all these criteria. Yep. Okay.